Thank God. Oh.
Yeah, it's yet another week. I hope your week was very fruitful.
Yes, Doc.
Yes,
By the
Doc.
grace of God.
Okay. Okay, so as discussed, we have treated some topics to the best of my knowledge. We have gone through introduction to computers. We've done, and that's computer software and languages were parts. We dealt with data communication and network. We have done introduction to operating system. Is that not it?
Yes, please.
We have done WW and the internet, or the internet and then the WW. Today we have some presentation from some group members, and I want you to get your notebooks and your pens and take some notes or make some notes whilst they present. After the presentation, for questions, please ask all the questions. I expect every group to try and put best in this presentation. Please, as stated, I'm going to use this as a form of assessment for you, or as one of the assessment for you. So I expect every group to put in their best. All group members, so let's assume that group one is presenting. I expect you to put your video on so that we know that you are part of the group and you are present as well. It shouldn't be that because it is a group work, one or two people will go and do the work and then the rest will just come in. No, no, no. It shouldn't happen. We want to check the level of involvement of every group member in the presentation. So Linda, I'm ready. Let's have the first group.
Group one, please, you can present.
Please, I can't turn on my camera. I learned I cannot turn it on because the host has disabled it.
Okay, go ahead. I will talk to them.
I will call Elvis right away.
Good afternoon, Doc. Good afternoon, class.
Good afternoon. So you introduce your members, introduce yourself, and then your members.
Yes, Doc. My name is Mary Eduboswan, the representative for Group 1. I'll be doing this presentation with my colleague Bernard Amwa. We are presenting on the internet and the World Wide Web. Displayed on your screen is the list of Group 1 members. Our objectives. Many people use the words internet and World Wide Web interchangeably, but they are fundamentally different things. Understanding the distinction between them helps us appreciate how modern digital communication works. Today, we'll be looking at introduction to the internet, history of the internet, internet application, introduction to the World Wide Web, web browsers, search engines, email services, and our conclusion. What is the internet? The internet is a global network of interconnected computers that communicate with each other using standardized communication protocols, primarily the TCP/IP. It is often referred to as the network of networks. So basically what we are trying to say is that the internet is a huge worldwide network, that connects millions of computers and devices so that people can actually share information, communicate with each other, and also have access to different services. Before we explore the topic in details, let's take a moment and examine the origin of the internet. So on your right is a typical example of the internet and then the devices which are being connected to it. We have the servers connected to it. We have some laptops connected to it. The history of the internet. On your screen displayed is how internet actually came about. It started from the ARPANET right until today, AI. We will take each one of them and then explain it bit by bit. We will start with the ARPANET. The ARPANET was the first major packet switch network and the foundation of today's internet. It was originated from the United States Department of Defense. Over decades, it connected research institution and adopted TCP/IP in the 1983, marking the start of modern internet. Before 1983, ARPANET used an older protocol called NTP. As the network grew, researchers developed TCP/IP and allowed different networks to connect more easily. ARPANET simply means Advanced Research Project Agency Networks, and the NCP means Network Control Protocol. So basically, the ARPANET allowed computers to communicate and also share information, but then it didn't allow millions of devices to connect like the TCP/IP is doing now for us. At this point, one might ask, what is TCP/IP and why was it developed? TCP/IP is a set of rules that enables devices to communicate over the internet. It was developed to ensure reliable and efficient data transfer between different network systems. The TCP/IP is actually the basic communication system that allows devices like the phones, the laptop, and servers to connect and communicate over the internet. TCP/IP was introduced in 1974 and officially adopted in 1983. This TCP/IP is organized into 4 layers. Let's have a look at them. We have 1, the application layer, where apps like browsers works. 2, the transport layer, where the TCP actually operates. We have the internet layer. This is where the IP also operates. And then we have the network access layer. This is where we can talk about physical connections like the Wi-Fi connections and the cable connections. Internet application and importance. Internet applications are tools and services that people use every day through the internet. The tools actually became essential worldwide during the COVID-19 pandemic. Displayed on your screen are some of the applications and importance of the internet. We can talk about the communication, security and infrastructure, education, information, e-commerce, and entertainment. When we take the communication, for instance, it helps people communicate instantly across the world. We can talk about the Zoom and the WhatsApp, etc. When we talk about the education, internet has actually made learning accessible everywhere. Information for learning, assignments, research, etc. When we talk about e-commerce, internet has made shopping so easy and convenient. We now buy and sell over the internet via apps like the Amazon, the Alibaba, etc. When we talk about the entertainment, internet has provided fun and relaxation through streaming of music, watching movies, and then video games. The future of the internet. 1. The future of the internet will be smarter, faster, and more connected. We will have higher speed with technologies like the 5G and many more. Everyday devices will be connected through the Internet of Things. 2. Artificial intelligence will make the internet more intelligent and personalized. 3. The use of visual and mixed reality will create more engaging and immersed environment. 4. At the same time, the security and privacy will improve, and many people around the world will gain access to the internet. Now that we have covered the internet, its application, and its importance, let's move to the World Wide Web. I would now hand over to my colleague, Mr. Bernard Amwa, to take us through the World Wide Web.
All right. Thank you, Miss Mary. And at this point, I would like us to take it a bit further by understanding how the internet operates using the World Wide Web and its other related associates. So before that, one may ask, World Wide Web, what is it about? And how did it come into existence? It's a system of linked web pages and resources accessed via the internet using a browser. It lets people view, share, and navigate information through websites, hyperlinks, and multimedia. The World Wide Web was invented in 1989 by Tim Berners-Lee. And inventing the World Wide Web involved growing realization that there was a power in arranging ideas in an unconstrained web way. So web arose as the answer to that open challenge. Berners-Lee proposed a system to enable researchers to share information using hypertext documents linked over the internet. Please note, the web is not the same as the internet. The web is a service that runs at the apex of the internet, allowing users to access and share information through web pages. Now here are the 4 key units or components of the World Wide Web. Number 1 is the HTML, the standard marked up language that structures web pages. Example, HTML defines headings, paragraphs, and links on a page. Number 2 is the URL, the address we use to locate web resources. Number 4 is the HTTP or the HTTPS, the protocols for transferring web content from servers to browsers. HTTPS encrypts data for secure access, which we'll be delving much more into. And also the web servers, computers that store and deliver web content for users. Now, analytical look at the URL. A URL means a uniform resource locator. It's basically the full address of something on the internet. It tells your browser exactly where to go and how to get there. It also works in collaboration hand in hand with the HTTP, how the browser connects the www, a subdomain like a section of the site, Google, the main website name, .com, the ending called the top level domain. And also, let's take a look at the structure of the URL. You could see clearly from the diagram, the URL works actually hand in hand with the subdomain, the Google, the .com. Together, they help your browser find the exact website. The next thing is the HTTP and the HTTPS. The HTTPS is the secure version of the HTTP, which encrypts data to protect it from being intercepted by unauthorized parties. Over here in the diagram, as we can see, while HTTP and HTTPS, we can say, serve the same purpose, HTTPS adds a security layer, hypertext transfer protocol secure. and also the HTTP over the SSL. The SSL actually means the secure sockets layer. Now, I would like us to observe the server and client relation with a keen interest, I must say. Servers are computers that store and deliver data, websites, and services to other clients, the other client devices over the internet. Clients are also devices, example, the laptops, the smartphones that request and receive data from servers. All this works interchangeably with the internet, as we can see in a diagram, whereby the laptop we are even using now sends and receives information via the internet. Same with our smartphones, and also the LMS portal we log into operates as the server for us, because we upload our assignment, we receive notification and so on from it. So we could clearly see when we log on to the LMS, which Doc actually puts an assignment on it, we all want to do our research work. We receive feedback on the LMS, meaning we are using our laptops, our phones to log in, to do our research works and so on. The feedback we are getting enhances our work, I might say. Another thing I want us to look at is the web browsers. A web browser is a software application that allows users to access and view websites on the internet. There are many web browsers available today, but here are some of the most important and widely used ones. We have the Chrome, we have the Mozilla, the Microsoft Edge, the Safari, the Opera, a lot more. And you can clearly see from day one, from the 1993, whereby the Mozart also came into place through to 94. The IE also came about in somewhere in 1995. The Firefox 2004. Chrome, a powerful tool we have all been using, also has also come into place right up to today. 2015 Edge also came. So there are a lot more web browsers available. So web browsers also works hand in hand with search engines. And here is how it also functions. But first of all, a search engine is a system that allows users to search for information online using keywords. A typical example is the Google, the Bing, the Yahoo, etc. And all of us here can attest to the fact that search engines played a key role in our research work, hence the effective presentation we are all having now. And how does the search engine work, you may ask? Kindly have a look at the diagram on your right. So it starts from the crawling stages, where web crawlers gather information from across the entire web. It processes it to the indexing stage, where gathered data is organized and categorized for rapid retrieval. Then also it moves on to the searching aspect, where query is processed and reliance ranked using proprietary algorithms. Then also displaying it to the most relevant results and presented to the user on the SERP. Now let's take a look at a model which operates collaboratively with the World Wide Web, the email services. The electronic email is of the oldest and most widely used internet applications. Unlike the World Wide Web, email existed roughly 2 decades before the World Wide Web. Somewhere in 1965, researchers from MIT, Massachusetts Institute of Technology, had created systems that allow users to leave digital notes for each other on the same mainframe computer. But Tomlinson's innovation allowed messages to be sent across a network. Today, services like Gmail, Yahoo Mail, Outlook, and many more are used by billions of people worldwide, which allows users to send and receive messages, file attachments over the internet. Despite the rise of social media and messaging apps, email remains the backbone of professional digital communication across the globe. Now, before we proceed, here are some of the challenges I want us to take note of. Number one, That's the security threat, the constant battle against malware, hacking, and unauthorized systems. Number 2 is the privacy issues, the loss of personal data control in an ecosystem built on information aggregation. Number 3 is the fake news, the rapid spread of fake news and misinformation. Number 4 is the digital gap between people who have easy access to internet and also those who don't. Now, looking ahead, the future of World Wide Web. It has actually expanded global connectivity. Hello?
Yeah, we can hear you.
Continue, we can hear you.
Please
Continue,
continue.
we can hear you.
William, can you mute your mic? You are distracting the class.
Hello?
Yes, sir, we can hear you.
You can
Continue.
proceed. Go ahead.
Okay. All right. Sorry, I think internet challenge. Okay. So looking ahead of the World Wide Web, it has expanded global connectivity. Day in and day out, the internet would increasingly connect people and devices worldwide through technologies like the Internet of Things, leading to more integrated and efficient systems. Today, a child at Shri Village, Kodiabe, all have access to global connectivity. Today, as we speak, advancement in artificial intelligence, AI, has advanced and will continue to enhance automation, improve data processing, and provide more personalized digital experience across various platforms. Also, it has also strengthened cybersecurity and data privacy, whereby greater reliance on the internet will require more advanced security measures and stricter data protection to ensure safe and reasonable usage. So in summary, and at this point, based on the topics discussed, it can be concluded that the internet plays a crucial role in modern society, such as enabling global communication, providing widespread access to information, supporting education and research, facilitating economic activities, digital commerce, and enhancing everyday tasks through online services and platforms. So, Sir Tim Berners-Lee, who often emphasizes its human purpose over its technical structure, placed everything we have learned so far in a simple quote. And I quote, "The web does not just connect machines, it connects people." End of quote. Thank you.
Thank you
Thank you.
to the class and to Doc. Our presentation to you all from Group 1. Thank you.
Okay, thanks a lot. Thanks a lot for the presentation. We'll open the floor for questions before I come in. These questions?
No
questions.
question.
No questions, doctor.
Please, I have a question. Please, can I go ahead?
Go ahead, please.
All right. So, I realized from the presentation that the web browsers, Chrome, Safari, the Microsoft Edge, and the rest, they all are more of like application softwares. Am I wrong? Hello.
Please finish with your question. We are listening.
Yeah. So, and when you got to the place we were mentioning the website also, you mentioned Google, Yahoo, Bing, and also they all are more of like web application softwares. So, with this, what differentiates them? Hello.
Please, what differentiates what? Like
Please come
your
again with
question
your
again.
question. Come again with your question.
Yeah. So I said from your presentation, you mentioned some examples of web browsers, and you mentioned some examples of websites. And what I know, Google is a it's an application software. Then we have the Bing also being an application. We have the Yahoo also being an application. So given that they are all application software, what is separating them from being the website and web browsers?
Okay, thank you very much for your question. I really appreciate your question. So the difference between the web browsers and the search engines is that for the web browsers, they are just a software applications which are normally installed on your devices, okay? And when they come to the search engines, these are the websites or the online services used to find specific information across the internet. So basically, this is the simplest differentiation I can give for now. Thank you.
Mr. Nathaniel, please, are you okay?
No, please. It's just like what you explained. But my trouble is coming from the fact that they are both like all between the website and the web browsers, they are all application software. So I'm a little bit confused on how you guys are differentiating web browsers from websites when all of them are application softwares.
Okay, so thank you. So the search engine is not just an application, it's a web-based service. Okay, the search engine is a web-based service. Whilst the web browser is a program normally installed on a device. Example could be just even the Chrome. You get it. You can install the Chrome on your device and all that. But the search engine are the web-based. Please do get it.
Likewise, I can install Yahoo, I can install Google on my phone. I can install it on my laptop.
You cannot install Yahoo on your phone.
Really?
Yahoo is a website, a search engine.
You can install Yahoo as an application on your phone.
Please, can I come in?
Okay.
Yeah, go ahead.
Yeah, please, like you use the browsers to access the search engines, like those Chrome and Safari and Edge. You use them to access the search engines. You get it?
Yeah.
Yeah.
Please, are you fine now?
And from what the guy just said, independently, you can use Google to search for something without passing through Chrome.
Yes, you can, because they are all web browsers that you can use to search for anything on the web. You get it?
Yes. So they are all web browsers.
Yes.
Okay.
Please, are you okay now?
Yes. If you are saying they are all web browsers, then I will take it.
Hey, they are all web browsers. That doesn't mean Google is a web browser.
Google is not a web browser, it's a search
So
engine. Google
is a search engine, and then Chrome is the
They are all web browsers.
please. Google is a search engine, and the Chrome, for instance, is a web browser.
Yeah, so you can't say they are
Yes.
all web browsers.
Yes. Please,
Yeah,
any other
sorry.
question?
Google is a search engine. Sorry for that.
Okay, please go ahead.
Mr. Ewache.
Good afternoon, Doc. Good afternoon. Please, the group one made mention of ARPANET. They said it was the first major pocket switch network. But I asked, why do I consider the 1983 the start of the modern network and not the ARPANET, please?
Please, we didn't hear you well.
Please,
Your voice is
please, you
very
didn't
low.
understand the question.
You said the ARPANET was the first major pocket switch internet. Am I right? Can you hear me, please?
Yes, please go on with your question.
And I'm saying that, how can I consider 1983 the start of the modern network and not the ARPANET? Because ARPANET was the first major pocket switch network before the 1983 start of modern network.
Okay, thank you. Please, before the TCP, there was a network, but the problem was that they couldn't connect millions of network systems or computers to communicate with each other or share information with each other. So they introduced this ARPANET. They use another protocol called the NCP. Okay. Then researchers developed TCP to allow different networks to connect to each other more easily. So yes, before ARPANET, there was a network over there, but they weren't being able to communicate easily as of today. Please do get it.
I get it, I get it. Thank you.
Mr. Kingsley, your question, please.
Okay, so please, I want to know the relationship between the TCP and the ATTP, and specifically identify which one belongs to the internet and which one belongs to the web. Thank you.
Please, you want to know the difference between
the TCP, that's the IP, and the ATTP.
ATTP.
HTTP, yes, please. And then which one belongs? I want to know which one belongs to the internet and which one belongs to the web, because he said there's a difference between the internet and the web.
Okay, so the TCP IP, okay, these are just a protocols. Before a device can connect into the internet like this, let me show this slide, sorry. Before a device can connect into the internet, they have to follow these protocols. For instance, if you want to set something on internet, it must follow these protocols. Okay, this is the protocol, the application layer, the transport layer, the internet layer, and the ATTP. But when you come to the ATTP here, this one is ATTP. This is the secure version. For instance, if you go to Google right now and if you want to set something, these are just also a protocol. Okay, these protocols is like a protection. If I visit a site and the site is not secure, if it's ATTP like this, meaning the site is not secure. But if it's a HTTPS, meaning the site you are visiting is secure. So let's have a look at something here. If you have a close look at this laptop making a request, you see that if you have a close look, you see that it has a HTTPS, meaning the internet and the site is visiting is secured. But if it is HTTP, meaning the site you are visiting is not secured. So that's the difference between them. So the TCP IP are just protocols. Any device connecting to the internet must follow that protocols before you can communicate. And this HTTP, the one you mentioned, these ones are just the protection to tell you that the site you are visiting is secured. So you shouldn't be afraid. And if it's HTTP, meaning the site you are visiting is not authorized and it's not secured, meaning you are being exposed. Please, is that okay?
Yes, please. But
you
haven't told me which one belongs to the internet and which one belongs to the web.
They all belong to the same. They all follow protocols. the awful protocols. I think I will leave this one for my friends to also answer.
Okay.
Hello, please, what is the meaning of the SSL?
Please, our time is going on. 3 more
So,
groups to present. So please.
SSL simply means secure shell. SSL means secure shell.
What does it do?
It protects you from being exposed on the internet. It's like a security layer attached to the HTTP. So this one protects you on the internet. It's more like a security, let me put it that way.
Okay.
So we have the SSL and we have Telnet, but today we just focus on the SSL. They are all security.
Okay.
Thank you. Please go ahead, go through.
Yeah, so mine is not a question. I just want to add something. During the presentation, the presenter said about the HTTP and the HTTPS. He said the HTTPS prevents, your information that you send over the internet from being intercepted. But actually, the difference is the HTTP, like when you send an information, it's being sent in the clear. So when an attacker intercepts it, the attack, like the person can actually see what you are sending over the internet. So the person can even modify it, and even if maybe there are some passwords and stuff in there, the person can steal it. But with the HTTPS, whatever you are sending over the internet is sort of encrypted, so the person can still intercept it. But when the person intercepts it, because it's encrypted, the person cannot really tell what information is being transported over the internet. So I think it's not that with the HTTPS it cannot be intercepted. It can still be intercepted, but when you intercept it, you can't really tell what is being transported over the internet. Thank you.
All right, thank you very much. Please, any other question?
The next group, please.
Since there are no further questions, we thank you very much for your attention. Thank you. How can I stop the slide? Hey.
Just stop sharing, that's all.
Yeah, I'm trying to stop sharing, but I can't see.
All right, group 2. Doc, please, group 2 is ready to present.
Okay, so can we pick the next group, please?
Hello, good afternoon, Doc. Good afternoon, colleagues. My name is Swabira Jibril, and together with my colleague,
Can I
will
comment
be
on the
presenting.
first presentation before you continue?
Okay.
Can I just comment on it before you?
Don't
worry about it. You can leave your PowerPoint, or you want to finish everything?
So let's finish everything. As we
Okay.
said,
So that's what you said
Okay.
last week, that you should finish
Okay,
everything.
so you finish everything. Finish everything.
Swabra, please turn on your camera.
Sorry, I'm at work. I can't do that, so pardon me. Okay, so good afternoon, Doc. Good afternoon, colleagues. My name is Swabira Jibril, and I'll be doing this presentation with my group members and then 2 of my co-presenters. Now, our topic for discussion is on input devices. We'll be exploring the tools and technologies that enable interaction with computer systems. Okay, so these are my team members. So under this topic, we have the input devices. We'll be speaking about the types of input devices, how they work, and then the types, under the types, we have the manual input devices, optical recognition devices, digital cameras, voice recognition systems, and then media input devices. Okay, so in today's digital world, input devices play a crucial role in how we communicate with computers, whether we are typing, speaking, or even touch. So let's take the definition for input devices. Okay, so input devices are hardware components that allow users to enter data and commands into a computer system. Now, their key role is to translate human actions into digital signals that computers can process. The types of input devices include keyboards, mice, scanners, microphones, cameras, etc. All right, so under the input devices, we have the manual input devices. These require direct physical interaction from the user, and this includes a keyboard, mice, touchscreens, graphic tablets, among others. And then also under the automatic input devices, these ones capture data without constant user input. So it doesn't necessarily have to use a human interaction to be able to give an output. Now, under that, the examples are barcode scanners, sensors, and cameras. So this classification helps us understand how different devices interact with users and then the systems. All right, so these are examples of some of the things I mentioned: the keyboard, mouse, touchscreen, joystick, barcode scanners, microphone, the guitar camera, among others. All right, so now how do input devices actually work? So input devices use different technology to capture data and convert it into digital form. Now, for example, a key sends electrical signals when keys are pressed, and then a mouse uses optical sensors to detect movements. And then also a microphone converts sound waves into digital signals. In simple terms, input devices act as a bridge between humans and then computers. Okay, so under the keyboard, let's take a closer look at one of the most important input devices, that's the keyboard. Can I? Yeah. Okay, so let's take a close. Like I said, the keyboard is used to enter text, numbers, and commands into a computer. The most common layout is the QWERTY keyboard, but there are others like the AZERTY and then the Wk5 designed for different purposes. So this is just an example of how what I mentioned looked like. So we have the QWERTY, AZERTY, and then also the Wk5 type of keyboards. Each of them have specified uses. So now the components of these keyboards, they have like alphanumeric keys, they are function keys, and then there are also specialized keys. Now the types of keyboards are, we have standard keyboards, we have ergonomic keyboards, we have gaming keyboards, and then also there are wireless and virtual keyboards. Okay, so based on this, we can actually say that despite its advantages like speed and accuracy, keyboards can also cause challenges such as ergonomic strain and then accessibility issues. Okay, so can we have a look at the examples of the... Yeah. Okay, so just like I mentioned, despite the these are some of the advantages. The advantages of the keyboards: versatility, which is capable of performing a wide range of tasks, from data input to complex commands. In terms of speed, we have skilled typists can achieve high words per minute rate, enhancing workflow. And then for precision, it allows for accurate input, especially with the use of modified keys and then shortcuts. Now let's look at the limitations of the keyboard. All right, so in terms of ergonomic, which is the design, there is prolonged use can lead to repetitive strain injuries like carpal tunnel syndrome. I'll come to that later. And then also the learning curve, non-standard layouts, example for the Zorak, for example, it requires a significant time to master. So it's kind of like a bit complex as compared to the QWERTY and then the other one. And then in terms of accessibility, traditional designs may pose barriers for users with certain physical disability. Okay, so now let's move on to pointing devices and then how these ones comes under the design of an input device. Now, optical recognition, pointing devices, they help users navigate graphical interfaces. Now, example of these, of course, is the mouse, the touchpad, trackball, graphic tablets, touchscreens, and these are examples of all these things I'm mentioning. And these devices allow users to control cursor and interact visually with the system. They are especially important in modern computing where graphical interfaces dominate. All right, so we will talk about how they also work. Now, mechanical mouse uses rolling balls and internal rollers to detect movements. And also for touchpad, they detect finger movements while compactive sensing to control the cursor. And then for optical mouse, it employs a LED or laser to capture surfaces images for important detection. And then for touchscreen, these detect direct touch into using compactive or recessive technologies. All right. So all these ones are important in modern computing where graphical interfaces dominate. Okay, so we'll move on to the technology and application of some of the pointing devices. So in terms of like general computing, I think I've mentioned this already. Essential for navigating operating systems and interacting with software applications. And then in graphic design, enables and crucial for drawing, photo editing, and 3D modeling. And then in gaming, their specialized mouse offer custom buttons, weight, and then high DP for competitive plays. And then in terms of accessibility, there are specialized devices like eye tracking systems that assist users with disability. Okay, so these are some of the key features like bottom and scroll wheel. I'm sure we all know how some of these things look like. Fortunately, I couldn't add. Please can we move on? Okay, so the next on the topic is optical recognition devices. Now, optical recognition devices use light to capture and interact with visual
please, Solomon
data.
is supposed to take over.
All right, so I'll just
please
end
proceed.
here.
Thank you, madam. I'm taking over and we'll be taking a critical look at optical recognition devices and with the introduction. So we are saying that optical recognition devices, they uses light to capture and interpret visual data. So they convert physical information, that is the text, the image, the barcode, into a digital data. They are essential for automating data entry and improving efficiency. So the types of optical recognition devices, we have the barcode scanners, as you can see from your screen. We have the optical character recognition devices. We have the optical mark recognition devices too. Then we have the image scanners. Then the last, the facial recognition. We are all using this so that it can make it clear for you with pictures and backing whatever we are projecting for you. So next slide, how optical recognition devices works. You can see with a clear pictures that the light or the laser or the LED or how you call it LED, you can see it scans data for you and it helps reflect light captured by the sensor. So we have the sensor decodes the information for you, then the digital data also proceed by the computer for you. So we have the application, the advantage of optical recognition. So let us take a critical look at the application and its advantages. So we have the retail. You can see we have the library, how it works there. We have the healthcare, how it works there. The banking too, at the education sector, at the security sector too. You see how all these optical recognition devices help. So let us take a look at the advantages too. The efficiency, as you can see, it automates data entry, the speed too, you can see, and the accuracy, and when it comes with cost effectively too, you can see. So digital cameras, we need to talk about it. So we are saying digital cameras. So digital cameras are electronic devices that capture and store photos, videos in a digital format. Unlike the traditional cameras, use image sensors instead of film. So we have the core components here. You can see the image sensor, you can see the lens, you can see the viewfinder, you can see the LCD screen, the processor, the storage, and the battery. So the types of cameras. So we have types of cameras. We have the compact cameras, the digital single lens reflex cameras. You can see with the back-end picture, and we have the mirrorless camera too. We have the action camera, then the smart camera. You can see, yes. So we have a key features of these digital cameras. So we have the resolution. It's helping measured in megapixels. And we have the zoom. They can zoom and do whatever they want. And we have the aperture too. It control light. You can see. And we have the shutter speed. We have the ISO sensitivity. We have it. It helps adjust the light sensitivity. Then we have the video capacity, as you can see. So digital cameras. We have digital cameras. So digital cameras, its applications and advantages. So we have the photography. Amateur and the professional use it. So we have the videography at the homes. You can see it helps for your films and the stuff. And we have the surveillance too, the security monitoring system, at the medical imaging too. We have the endoscopy, the microscopy, and the stuff. And we have the astronomy too. It's a celestial object imaging, and the social media, creating content and sharing content, and then. So let us take a look at the advantages too. Instant preview. So when you can preview instantly. You can see whether the picture you took, it looks nice or no. Do you want to delete, or you need to take another shot, you can do that. And it helps with high quality too. So nowadays you can see our pictures we are taking looks high, like picture quality, everything is 100%. So we have the versatility too, a wide range of applications, editing, flexibility to easy posting, processing. So I'll pause here for my brother Solomon to continue from here.
All right, so we also have voice recognition systems. And when we talk about voice recognition system, they are systems that enable us to capture voice and interpret it into the computer system. And it can also convert whatever we say into text for us. Now, what are some of the key components of voice recognition system? We have the microphone, we have the analog digital converter, we have speech recognition devices, we have language monitors or models, we have acoustic models, then we have the dictionary for also which converts words or spoken words into the digital format for us. Then what are some of the key features? Now, how does this system works? One, voice is captured into the computer system through the microphone. The analog signal is converted into the digital system. Then from there, it is extracted through the frequency and then amplitude. Then it is now matched all right, with how the dialect is spoken or that language have in models. Then from there, it is converted into text where we can see the text being written clearly for us. What are some of the voice recognition applications and advantages? Now we have virtual assistants like the AI, the Siri, the Alexa, the Google Assistant. We have accessibility, the hands-free devices that we have, all right, that help users with disabilities. We have healthcare, medical note dictation, and also patient record can also be seen from these devices. We also have customer service, like the call centers that we have for various mobile telecommunications that we have. You call and someone answers, not human, but rather voice automation. We have also automotive, that is navigation systems, entertainment, communication. All this made possible by voice recognition devices. We have home automation, where we have smart home devices that can control our whole home just with voice commands. What are the advantages of these voice recognition devices? Hands-free, as we said, that we don't have to input anything manually. We have accessibility, where we have alternative for physically people who have disabilities physically. Then efficiency when it comes to speed and data entry, because we speak, the computer system captures it. Then natural interaction also is reduced, where you don't have to interact with the computer system directly, but you just speak and it picks your voice as it needs. The next slide, please. Then voice recognition trends and challenges. Now, what are some of the challenges when it comes to voice recognition? Now, accuracy, all right? Sometimes background noise helps or makes it more difficult for us to be able to capture voice into the computer system. And we have privacy concern, where voice data connections and processing, sometimes it goes beyond our privacy. Then we have complexity, requiring some significant amount of computational resources in order to be able to do the conversion. Then we have language limitation. You know, the number of languages we have in Ghana, the computer system takes it difficult or sometimes find difficult to recognize each and every dialect and how it is spoken accurately. Now, what are some of the future trends when it comes to voice recognition devices? We have AI and machine learning. Then again, we can convert a contact awareness, understanding how this voice recognition devices work is able to help us and support us when it comes to multi-language devices, because nowadays AI is helping to convert a lot of languages, so we are able to now have trends of that nature. When it comes to emotional recognition detection, we are able to detect our emotions, so we move our hands and we see that devices also move along as we move. Then edge computing, local processing for improved speed and privacy. These are all made possible because of voice recognition devices. Next slide, please. Good. Then media input devices. What are media input devices? They are hardware that capture and input different types of media directly into the computer system for us to see. So they can create, they can edit, and they can share these media input devices. So we have the microphone capturing audio sound, webcam, we have scanner, we have multi or musical instruments, which is able to convert musical notes into music for us to hear digitally. We have digital cameras, then we have the graphic tablet. These are all features of devices that are able to convert, and we see it so nicely. How does media input devices work? Now, microphone, as we said, it converts waves of sound into electrical signals so that we can digitize it. All right. We have the scanner, which is also converting light, all right, based on the image captured into digital format for us. We have digital camera capturing light through the lens and convert it to digital data. We have the webcam which uses the lens and focuses the light and transfer the image onto the digital frames for us to also see it digitally. Then we have the media or MIDI controllers, which sends signals in the form of notes or musical notes for us to see those musical beats that we have. Graphic tablet uses the stylus pen, all right, to create graphical images. So our mobile phones that we see are designed using some of these graphical tablets. Then they even design cars and various other input devices or other devices as we see. What are the key features of these media input devices? Resolution. Now, level of digital input devices have immense or have broadened, and now we are so much interested in the megapixels and DPIs. So we see our images very clear and very sharp as it sounds. Then sensitivity, ability to capture the level of sound and light accurately. Then connectivity, we use several various means to connect this kind of digital input devices to our computer system. We use the USB, we use the HDMI, we use the Bluetooth, and sometimes we use the Wi-Fi to connect these devices to our system. The compatibility, they are compatible to a wide range of operating systems. The Windows, the Ubuntu, the Mac, they are all able to connect these devices efficiently. Ergonomics, they are designed for comfort during prolonged use. So we feel comfortable using it and not very difficult when it comes to the usage. Then what are some of the application of these media input devices? Now we apply them with the multimedia production. So if we are doing multimedia production, we use these input devices and they are very efficient. In education, we use them sometimes creating instructional lessons, just like we are enjoying now. Yeah, we enjoy these interactive discussions and lessons. Entertainment, we use them in the gaming and VRA for immense experience. We are able to be in the game. Sometimes we be in the movie because of this VRA and enhanced technology that we have. Then communication, video conferencing, live streaming, and then online meetings as we're having, we use these devices. Then healthcare, we use this to take image and diagnosis even in the internal organs of our human body. Then document management, we are able to use these digital devices to capture the hard copy documents into the computer system to archive them for future use. Yes, so these are the wonderful features of these input devices. Now, the conclusion or the takeaway from this discussion that we've had this afternoon, input devices are essential when it comes to their usage, all right? They are components that help us to interact with the computer system. They are able to convert actions that we depict and then turn these actions into digital format for us to see on the computer system. Yes, there have been enhancements from the old traditional way or traditional systems into the modern ones that we can now, the system can recognize our voice, can see us as we move and recognize our emotion as well and convert this into digital format for us. So that is a modern way of accessing devices and also capturing data into the computer system. Now, what are some of the future developments? We see AI venturing into this area as well, and we benefit from using this computer. This is where we got all these references from, and it has really helped us to be able to present these materials to you, dear friends, as well. We thank you, and we appreciate your attention and welcome any questions about input devices and their application. Thank you.
Please, only 2 questions because we are behind time. 2 questions, please.
Okay. Colleagues, do you have any question for them?
My God.
I have a question.
Okay.
Please go ahead.
Please go ahead.
During the presentation, Mr. Solomon talked about something called language model. Can you please throw light on that? I don't know. Is it a device or what? A language model.
Okay, my name is Safiano Suleimana. I'm part of Group 2. A language model is artificial data that is software that is filled up with data that can be referenced So when it's stored in the computer, when somebody is making an input, then the computer will reference it and use that to match it. Please, do you understand?
Oh, okay.
So it's like a database of various language, all right? So the computer make reference of it and then translates it with the text for you to see the text image of it.
Hello, I have a question. Please, can you open slide?
Please go ahead.
The slide 32. I saw something there. Yeah. So with the healthcare, can you give me any example of device like that?
Yes, we have the MIR machine, which is an input device, and then there's a direct input device scanning the human body, and we see when they want to detect some challenges with sometimes even the bone or something happening internally, they are able to do that.
Okay, and to add to that, X-ray machines are also examples, and then also the endoscopic cameras. They also are also input devices. Ultrasound scanners, all of them are parts.
Okay, so please, because time is moving, please let us do it fast.
Okay, please, what is the difference between gaming keyboard and the standard keyboard?
Okay, a gaming keyboard has extra features like a mechanical keyboard, or to help enhance the gaming. Like when you press the keys, they respond much faster as compared to a standard keyboard. That's the only difference. Thank you.
And also the gaming keyboard is designed specifically for gaming. So it has extra features specifically for gaming. But with the standard one, I think it's sort of general.
Okay, please, when you say it's a gaming keyboard, it's a mechanical keyboard, please, what does it mean? I don't understand.
Okay, so I think what he wanted to say is that the gaming keyboard, all right, have sometimes extra keys attached to them to make it more efficiently when it comes to gaming. All right, so sometimes we may have some controllers and some ergonomics or some design features that makes it more relaxed when you want to play game with it. So I think that is what he was referring to with the mechanics that he said.
Oh, okay, thank you.
Please, my question.
Please.
So I have a question.
My question, please.
Yeah, so on the voice recognition, so I want to ask, how does this voice recognition input devices manage to filter out background noise to ensure it only inputs the intended command? So if we're giving a command to a voice recognition input device, how does it filter out the
we indicated that those are some of the challenges that we face in regard to voice recognition systems. But because of future trends, systems are being developed, and then AI is also used to enhance, to filter out those noises and pick out the accurate information that the person wants to put in. Thank you.
Please,
Doc, please, can we proceed?
Please, last question.
We have two more groups to present to.
Last
Can we
question.
proceed?
Last question, please. Why are device drivers essential for input and output devices to function properly?
Yeah, so some device drivers comes with enhanced features for the device to work, all right, making the device more accessible and then more active, right? Some device drivers are able to enhance some of the features of the devices themselves and controls them better. So when we're capturing some image or some sound, this device drivers, because it's updated, is able to do the capturing better, process it faster, and then able to give us nice and then presentable output, as we have already said.
Yeah, I want to add something. The reason the device drivers are important is that like they are the link between the device that the input device you want to use and your computer. Let's say for instance, if you have a mouse right now connected to your computer, is the device driver that is sort of the link between what the mouse and the computer system. Okay, so it's sort of that like it's like the middleman. It connects your device to the computer. Without a device driver, your connected device will not be able to communicate with your computer. Thank you.
Thank you, group two.
Hey, can
Please,
I
group
ask my
four.
question?
No, please. No, please.
Hey, Ferdinand, why are you running away from questions?
We have two more groups to present today, and we have next class starting at 3:30.
This money, my bad.
Group two, can you stop sharing your screen? Group four, please get ready.
Good afternoon, class. Hello.
Good
Yeah,
afternoon.
hello.
Good afternoon.
Hello, good afternoon.
This is group 4, and I'm Oti Emmanuel. You are to present on computer organization. And these are the members of group 4. But before we proceed, we would like to talk about computer, what computer is, organization and architecture. When we say computer is an electronic device that process data into information. And when we talk about organization, it's a set of rules or how to arrange something or putting things in place, putting things in order. And when we talk about architecture, you can take a building or a system, the blueprint, or the building plan of a system. That is what architecture means. We move on to our key topics for today's presentation. That's computer architecture, primary areas of computer architecture, advantage and disadvantages of computer architecture, computer organization, primary areas of computer organization, advantage and disadvantage. We move to the differences and importance of computer architecture and organization. So now we'll talk about computer organization. Computer organization architecture explains how the computer hardware is designed and how components interact, how instructions are processed, and what makes computer system function effectively. So we are come to talk about the bridge between the hardware and the software, how they come together to perform a particular task. So with the computer architecture, it refers to the overall design. It refers to the overall design of a computer system, including the hardware and the software components that makes up the system and how they interact with each other. And move on to the types of computer architecture. There are various types of computer architecture, but for this presentation, we'll talk about Neumann architecture. You have advert architecture, instruction set architecture, microarchitecture, and system architecture. I will talk about John von Neumann architecture. So move on. With the John von Neumann, his concept was adapted in 1945, which is the foundation of all modern computers now to present. So if you check the diagram below, you can see this one, the chart flow of how John Neumann plan is architecture. You have the inputs and outputs units, the CPU, and the memory. We come to the primary areas of architecture. You have the inputs, you have the CPU, you have the outputs, you have the memory, and you have the system bus. But per the diagram, if data is being entered through the input device, it goes straight to the CPU, which the CPU is divided into two parts. That's the control unit, the arithmetic logic unit, and other parts as the register and cache. It processes the data. All these are the parts of the CPU has its function to play. So after the task given to each part, they process the data. Some informations are saved to this one, the memory unit, that's the primary storage and the secondary storage. Data, it gives feedback to this one, the output device. So that's the primary areas of this one, the computer. So as I said earlier, the CPU, it includes the arithmetic logic units, the register and the control units. The logic unit performs all the calculation in this one, the logics. Once as it performs, the register, this one, is an internal memory, so it saves the processing, the data that is being processed. And the control units manage this one, the instruction. Later, it's sent it to this one, the output device. We move on to the memory. The memory is the memory in computer architecture refers to how computer memory is structured, arranged, and accessed. So from the diagram below, you can see the types of memory architecture, how this one memory is being arranged. So you have the primary memory, the secondary memory, and memory hierarchy. With the primary memory, you have the RAM, the read access memory, the read only memory, and the cache. And if you come to the secondary memory, you have the hard disks, you have the solid state disks, and the flash drives. And if you come to memory hierarchy, you have the register, you have the cache, you have the RAM and disks. So that's the illustration of how the diagram is showing. We move on to input and output device. With the input and output device, the structure refers to how a computer system manages the communication between the CPU and the external devices, such as the keyboard. So with the input, we have keyboard, mouse, scanner, and the output, we have monitor, printer, speaker, and so on. We also have system buses. With the system bus, it deals with the communication. How wires are being connected together to be able to communicate with each other. So with the system bus, we also have some main types, which are three. You have the data bus, which transfers data, and address bus, which carries memory addresses. You also have the control bus, which sends control signals to other components. Move on to the advantage of a computer architecture. The advantage, you have performance optimization. This is designed to, it is designed not to advance the efficiency of a system by a significant percentage. And we come to the flexibility. Flexibility results in the capability to adapt and incorporate recent technology as well as accommodate the different hardware components. And we come to scalability. It should be in a way such that there is no provision made for future expansion of a building. And if it comes to the disadvantage of computer architecture, we have the complexity. It will be challenging and huge task, which involves the consumption on how the flow of design and optimization. And if you come to the cost, high performance architecture means expensive equipment, parts, and some parts. Sometimes that is why they are more expensive. So for you to have a good system working, you have to get expensive components in building your system. We move on to computer organization. So as I said earlier, the computer organization refers to how the computer works internally. It focuses on the physical implementation of the computer system based on its architecture. It deals with how different hardware components like the CPU, memory, and input device are connected and work together to execute a task. We move on to the primary area of computer organization. You have the data processing, data storage, control signals, and memory hierarchy. We move on to data processing, how data is being processed. Before data will be processed, before data is processed, the data is being input through the input device, which goes to the CPU to be processed. So with this, the control unit and arithmetic logic units have their role to play. After that, it sends to this one, the storage. So the data is being stored in the register. Then this one, the main memory and other secondary storage. That's the solid state drives, flash drives, and hard disks. Data is being processed out through this one, the output device. We also have data storage levels. So the main levels of data storage, you have the register, you have the cache memory, you have the main memory, secondary storage, and tertiary storage. With the register is located inside the CPU, same as this one, the cache memory. And the main memory, that's the RAM. If it comes to the secondary storage, that's this one, the hard disks. The hard disk or any external. That's part of this one, the storage. But when it comes to the tertiary storage, it entails on this one, backing up this one, using our cloud, like iPhone Cloud, OneDrive, Google Drive, and so on. We move on to control signals. With the control signals, the electronic signals generated by the control units of the CPU to manage and coordinate all operations inside the computer. It tells each hardware parts what to do, when to do it, and how to do it. There are also types of control signals. You have the data transfer control signal, arithmetic logic unit control signal and instruction executed control signal. So move on to advantage of computer organization. We have the practical implementation. It offers a perfect account to the physical layout of the computer system. It cost efficiency. Organization can help in avoiding wastage of resources, hence resulting in reduction of cost, and it's reliable. Thus, organization helps in guaranteeing that similar work produce similar favorable results. We come to the disadvantage of computer organization. We have hardware limitation. The system performance is limited by the physical layout of the computer system, less flexible. The organization is, however, a lot more well-defined and less easy to change once one setting is done. And we come to the difference. Computer architecture describes what the computer does, whilst the organization describes how it's being done. It deals with the function behavior of the architecture deals with the function behavior of the computer system, whilst the organization also deals with the structural relationship. And the architecture also involves the relationship among logical attributes of the system, like instruction set, data type, addressing, modes, and so on. Computer organization also involves the relationship among these other computer system, like this on the circuits and peripherals. We move on to the importance of computer organization architecture. It improves performance optimization. It helps understand the computer function. It supports troubleshooting and system maintenance. It helps in designing hardware and software. And we come to the conclusion of our presentation. The computer organization and architecture work together to provide a complete understanding of how the computer works from both structure and operational perspective. The computer architecture also explains what the computer does, whilst the organization explains how the computer works. The architecture is also concerned with the overall design of the computer system, while organization is concerned with the way in which the hardware components of the system are arranged and interconnected. This brings us to the end of Group 4 presentation. Any question? Hello?
Hello.
Hello.
Please, what's cache? And what is the purpose of cache?
You said cache.
Yeah, cache.
With the cache, you can store, let me use this one, our phone as an example. Maybe there are some files you deleted on the phone, but with the cache, it's like something permanent, unless you yourself wanted to delete on it. So it's a memory that stores files.
Let me
But
come
that is
inside.
embedded in this other system.
Let me come inside. I'm Philip Safo. You see, when we talk about cache, it's just like a temporary storage that holds sites or areas that you frequently access, so that it can be retrieved faster in the future when you want to access it. So that's the main what is cache when we talk about. Cache is just a temporary storage. Okay, I believe you understand.
Okay, okay.
So are there any questions? Are there any other questions?
Please, not from my end. I don't know
Yes,
whether your colleagues have some questions for you.
yes, Doc. We're listening, Doc.
So I'm saying I do not have any questions from my end.
Okay, Doc.
So I don't know whether your colleagues have questions to ask. Linda. Hello,
Yes, Prof.
Linda.
Yes, Prof.
Yeah. How many groups are we taking today?
We are taking 4, so left with group 10.
Group 10 to present.
Yes, please.
Okay. Can they do that fast?
Okay. Okay, thank you very much. If there are no other questions, we
Yeah.
say thank you to Doc and the whole class for listening to our presentation.
You are welcome, Senior.
Group 10, please, can you start sharing your screen?
Good afternoon, Doc.
Good afternoon, please. How are you?
I'm fine, thank you, Doc. And good afternoon, fellow colleagues.
Yeah.
Okay.
Oh,
So this is group
afternoon.
10.
How are we? Great.
Yes, sir. So this is group 10. We are 13 in.
Is that doing
No,
let me show you their office.
I am Millicent Opoku Mensah, and I am here with my co-presenters, Edward Boyson and Nathaniel Bequin. And today, we are also here with 10 other group members, all present. And today we are presenting on the topic data communication and networking. In today's digital world, communication plays a very important role in our daily lives, from sending messages to accessing the internet. But how does this communication actually happen? In this presentation, we will explain into details the fundamentals of data communication, including key concepts such as protocols, transmission methods, and how devices connect and exchange information. So the agenda, this is what we are going to cover: the core concepts, addressing and protocols, devices and media, and real-world skills. So without wasting much time, go straight to the point. So I would like to call on Mr. Edward Boyson. No, sorry, Nathaniel Bequin to kickstart, dive
All
into
right.
it. Thank you.
Thank you, Millicent. Good afternoon, Doc, and colleagues as well. Good afternoon to you all. Millicent, can we please start with a slide? Eddie, can we go to the first slide from my end? Next, please. Okay. So we are talking about data communication, and one would ask that what is data communication? It is basically the process of sending and receiving data between two devices. All right. So data communication is basically sending and receiving information between two devices electronically. And so we can look at our WhatsApp messages, how you send a message to somebody who is also having a different device. You send from your phone, it goes through a Wi-Fi over a router through the internet, and it gets to the person's phone. Aside that, we say that if you want to get an information over the internet, you just have to go on your browser, you enter the site that you want to retrieve the information from. There is a process that goes on the background, and it's furnish you with the very information you want. And so these are some of the things that we are looking at. And a typical example too is in our offices where we have a printer and a laptop where we want to print a document. You just send your information over to the printer through a wired cable, or sometimes if the printer is a wireless device, you send it through the wireless to the printer and it print. So it's the communication over here that we are looking at. And so the analogy here is that like mailing a letter, a message is sent, a message is a data, the IP is the address. The IP over here is the address to which you are sending the data to. And the router is the post office that transmits the whole thing. The next slide, please. And we are going to look at the component of our data. We are going to look at the 5 components that we have when it comes to our data communication systems. So we have the sender, we have the receiver, we have the message, we have the medium, and we have the protocol. So when it comes to the sender, we are looking at the devices like our laptops, desktops, our phones, our iPads, and all that. These are the components under the sender. And then we look at the receiver. So the receiver, we have the service, i.e. the Gmail, the Yahoo Mail, and all this. And then we also have the message, that is the data, the information you want to send. That is the message here. Then the medium. So if you are sending a message across, through which medium do you want to send it? We have the Wi-Fi medium, and then we have the Ethernet cable medium, where we have physical connections. But the Wi-Fi, you don't see the connection, it's just connected wirelessly. And there are protocols that it goes through. We have the SMTP, we have the HTTP, HTTPS, we have the TCP stroke, the IP. And so let's look at the flow here. The flow is that when somebody has a laptop connected to a router, the router would grant you access through the internet. You hit your Gmail server and the message goes across. And same way, if there is a reply, it goes through the same procedure and it comes back to the sender. So that is how data is being communicated over here. Let's look at the next slide. Now we look at networking. For you to have your data sent across, there should be some kind of network that you go through. And so we define networking as a practice of connecting 2 or more devices together so they can share information, resources, and communicate with each other, whether across a room or around the world. And so we look at sharing resources. Use one printer, one internet connection for more devices. We look at the communication bit, where we send message, emails, files between devices instantly. And you can have access to it anywhere, connect to a data or service from any location. And so basically, the going forward, I will explain the topologies that we have when it comes to networking. But when we talk about networking, it's just trying to enlighten us on how we are able to transmit data from one device to the other. All right. So think of it like this, like a road system. Devices are the cities over here. The cable or the Wi-Fi are the roads, and the data is the traffic moving between them. Okay. Let's go to the next slide, please. All right. So we talk about the kind of networks, the types of networks that we have. We have about 5 of them, but for our slides, for our presentation, we are trying to limit ourselves to just 3 of them. We have the LAN, we have the WAN, and the WLAN. We can also talk about the MAN and the PAN, but for our presentation, we are talking about these 3. So the LAN basically is the local area network, which is commonly used, is the most commonly used one. For especially for small setups, for small companies. You go there and you see the LAN connection being done. As for small, as I said earlier, a small area, office computers connected together, fast and private. So that is where we use cable connection, the Ethernet cable connection, to secure connectivity through a router and stuff. Then we talk about the WAN, which is a wide area network that is basically for a large geographic area. So you can have one company here in Ghana. So an example is like MTN in Ghana and MTN South Africa. They use a wide area network to communicate between the two companies. They use that to send and receive information. And we have the WLAN, that's a wireless LAN, which is a local wireless network home Wi-Fi. And so we have this kind of network that you can set up in your own house, where you have your phone connected, you have your um, laptop connected, you have your TV connected, and you can send and receive information across. All right. So can we move to the next slide, please? Yes. So we talk about, again, 4 essential network devices that every network officer must know about. We have the router, which connects your network to the internet, directs traffic between the networks. All right. So think about a traffic police. That is the basic work of a router. So the router acts like a traffic police. And then we have the switch, which connects multiple pieces within the same office network. Multiple pieces within the same office network. So that one too, as a layperson, you can think about an office receptionist who direct calls left and right. So a boss calls, I want to speak to so and so, they'll connect. I want to speak to this one, they'll connect. A new person comes in, I want to see this person, they'll call and connect. So that's the basic work of a switch. Then we have the access point that broadcast that one also broadcasts the Wi-Fi signals. And so if typically you enter a place like a mall and you want free Wi-Fi, you just go onto your Wi-Fi, you check and you see a list of Wi-Fi's over there. What makes you have access to these Wi-Fi connections is the access point. That's broadcasted for us to have access to it. And we have the modem, which is a bridge. It bridges your ISP, that's the internet service provider signal, to your router, i.e. the gateway to the network. So that's the basic work of the modem. And if we look at the flow, it is ISP cable to the modem, to the router, to the switch, and to the PC. So that is basically it with the essentials of network devices. Can we see the next slide? Now I would end here with my slides. We talk about the transmission media. We have 2 main transmission medias, and that is the wired media and the wireless media. So the wired media, we look at the Ethernet cable, which is referred most of the time in our offices as the internet cable. You hear people say, give me the internet cable, give me the internet cable. It's called the Ethernet cable. So it's a standard office connection, reliable, fast, and it has low latency. And we have the fiber optic cable as well, which is the ISP backbone, extremely high speed, and it's able to send long distance data as well. And so if we recall, in Ghana, I think years back when Glo was coming into our space, we remember that you would see people digging our roadsides and trying to put cables down there. So that was the fiber optic cables they were trying to bury on the floor there, so that they can use it to transfer data across. Then we have the wireless media, where we have the Wi-Fi and the Bluetooth. So the Wi-Fi basically is for home and office wireless, convenient, slightly higher latency. And then we talk about the Bluetooth, which is for short range devices pairing. You can go ahead to talk about the infrared and the other stuff, but currently is these ones that are kind of common in our system. So at this point, I will hand over the presentation to Edward to continue from the IPs. Eddie.
Thank you, Millicent. Thank you, Nathaniel. Good afternoon, Doc, my fellow classmates as well. I take over from IP addresses. I hope I'm audible enough.
Yes, sir.
Yes.
Hello?
You got
Yes.
Okay.
Yeah, clear.
So, what is an IP address? An IP address is a unique identifier assigned to every device on a network, like a home address for your computer. So, assuming you have a router in your house, normally you might have a SIM router or Wi-Fi. So the SIM router or the Wi-Fi has its own IP address. An example here is 192.168.1.1. And what it does is make sure that it gives every device that connects on the network an IP address via what is called DHCP. So DHCP is a default setting in your router that automatically assigns every device that connects to that very device, that's the router. So your phone connects to the router, your office PC connects to the router, and the router chooses to give that particular device an IP address just to make it known on the network, just like we have houses and they have house numbers. So that you can identify that this phone connected, this laptop connected to the device, so you can see what is actually on the network. So for us to have a good data transition, for us to have a good communication between data, we have to understand these protocols, which is the HTTP, the HTTPS, FTP, SMTP, and DNS. So how do these protocols work together? They're giving us an example here. So it's like every time you visit a website, maybe you are trying to access Gmail to send a mail. This is going on in the background. You enter your URL, that's maybe gmail.com or yahoomail.com. The DNS result, because what you type is google.com. It has to be transmitted or it's changed into an IP address because the network communicates with IP address, not google.com as we see. So before you can get access to whatever resource that you want, the DHCP, the TCP, the HTTP, and the IP are working in the background to make sure you can have the exact resource that you are looking for. And we have FTP as well. With FTP, you have a local server at the workplace that you can access sources from there. So you can do your backups there. You can as well send certain files there as well, or retrieve them from the particular FTP server.
Time is up.
Oh, so are we to stop?
Ferdinand, please give us some few minutes to finish up, please.
Okay, so let's go to the OSI model. Let's move to the OSI model. The OSI model describes how data travels from your application to the physical wire and back. So, an analogy here.
So, Lynn, who is presenting now? Which group is this, please?
Group 10.
Group 10.
Okay, try and wrap up.
All right, sir. So we have an analogy here of how the OSI model works. So in case you want to write a message, the application layer takes care of writing the message. You pack it and label it with a transport and network layer. The transport and deliver, you're going to use the data link and the physical layer. So the OSI model is telling on how the data we are supposed to send to a particular person moves across the network. Okay, so we have TCP, UDP. There are also protocols that will help us send our files accurately and with speed. Okay, let's move to the troubleshooting part. Let's glance through this area. With troubleshooting, it's necessary here because you might not have your network working and you want to know why it's not working. So first off, you check if your internet cable is plugged in. Then you check on IP config to see if your gateway, which is the router, is active. Then you ping your router's IP address to see if your router is actually on or there's nothing wrong with it. So if you happen to see your gateway in the IP config, you ping it and the router is okay, you have to check if the internet is going to work. And you do that by pinging 888, that's a Google DNS. Or if it goes through, you know that, oh, the internet is okay, it works. If it doesn't go through, probably you don't have data or there must be something wrong with the ISP. Okay, so we have different network topologies as well. That's how networks are designed physically. So it depends on the type of topology you want and what your use cases are. So we have the star, the bus, the mesh, the point-to-points, the ring, the tree, and the hybrid. And also with sending and receiving data, we have to know about bandwidth and latency. So latency is mostly about high bandwidth, like a bigger road, so more cars can pass through. And latency is about how long data travels on a satellite. So if you have a satellite like a Starlink, it's high latency. So a long road with a lot of lanes. So that one, your network isn't slowed down. So if you have an old network like the 3G and the 2G, it's very slow. So there's a distinction between the bandwidth and latency. So let's move to security and wrap up. With sending data across the network, you need to be secured, because if it's not secured, you might have somebody hacking your system or spoofing your data, and the data might not go to its intended destination or will compromise. So every network has security, which is a firewall, which blocks unauthorized traffic. So you don't access websites that may be malicious, or you don't access websites to consume work data. Maybe you might be on Facebook, you might be on Twitter and YouTube to consume the work data. No. There's VPN too, just to allow you to work from home. So you can access the resources at the workplace. And there's a common antivirus that we install on our machines to make sure our machines are not easily attacked by viruses and so on and so forth. And we touch on the last part, that's on passwords. So when you are setting up a password, you make sure your password is secure. You don't choose ASDF as 123. No. You choose a very secure password too, because that's the first entry of security. So if your password is weak, you just can go to your PC and get whatever they're supposed to get. Okay, so let's go through the summary and wrap up. So we touched on data communication, which is the process of sending and receiving data between devices through a transmission medium. We touched on IP addresses, DHCP, a router and what the switch does, the DNS, the TCP, UDP, which is a transfer protocol, went through the OSI model of how runs across the network, and went through a troubleshooting step to see how we can address situation when the network is not working. I think we are done here. Thank you, fellow classmates, and thank you, Doc.
Okay, thank you, Doc. Please, we have come to the end of our presentation. Thank you.
Okay.
We leave room for questions.
Yeah, Millicent. Millicent, please share your PowerPoint with your course rep, okay?
Yes, sir.
Yeah, please, I have them. I'll just forward them to you.
Yes, please. I have to review them so I can comment on them, please.
Okay, Doc.
Yes, I
Okay.
will do that.
Okay,
Thank you.
thank you. Welcome. I guess we are done for today. Linda, are we done for today?
Yes, Doc. Please, we are done.
Okay. So next week, how many groups more? Hello, Linda.
Yes, Doc.
Yeah, how many groups more?
We have 3 more groups.
Okay, next week we'll finish with these groups.
Yes.
Okay.
Yes, please.
Thank you. Please enjoy
Thank
the
you,
rest
Doc.
of the day, please.
Thank
All
you,
right,
Doc.
then.
Thank you too,
Okay.
Doc.
Thank you,
Okay.
sir.
Thank
Bye.
you.
Thank you. French energy, French anytime bow. Okay, you have to get off this platform and join the French group.
No, please. The French class is
The
not
French
coming on
is not taking place, so because of the midterm. So
at 9 p.m.
yes, so
Oh,
it's just
so
so you can
we are not having French today.
yes, so you can go to the
We will
Telegram
have it, but it
platform
has been shifted.
to
Okay,
9. You
9
can go
p.m.
to the Telegram
Hey.
platform and see.
It said 9 in the morning tomorrow or 9
Evening, this
p.m. this
evening,
night.
9.
PM.
Hey. Okay. 9 p.m. They are very
And we are using
See, the network is breaking, so I didn't hear. The French, will the French come? 9 p.m., 9
It says
p.m.
9 p.m.
9
9
p.m.
p.m. Night.
Hey,
9 p.m. when
group
you are
3, they
sleeping.
mark clock you. 9 p.m. to 12:30 a.m.
No,
9
we are
p.m.
using just 30 minutes. We are using just 30 minutes for the session.
They have like 4,000 sites. So.
So I'm
He's
forwarding the
doing well.
video.
He's doing well.
We start at 9
No, it's
p.m.
fine. It's fine.
The link will be sent to your reverse about 5 minutes to time. So all you have to do is to click on the link at 9 o'clock.